Hello. Uh, yeah, we're about to start. Uh, okay. Okay. Can we start, sir? Hello.
Sure,
Can you,
I'll get started.
okay. Let me introduce you, and then we can start the session.
Okay, sounds good.
Okay. Welcome, everyone. Uh, Thanks for joining this session, everybody. Let me introduce you to the Gokul Alex. He is known for the digital technology courses, and he is very well known for artificial intelligence, blockchain, cybersecurity, and other technological courses. He is also co-founder of many technology companies. Uh, he is one of the top in India's top blockchain experts. It is a pleasure to have you in the session, sir. Now we can start the session.
Yeah. Thank you, Digvijay. Thank you,
Yes, sir.
Priyadarshi, for setting up this wonderful session with our friends across different parts of India. It's my pleasure to talk to you about blockchain technology. And at the same time, I wish all of you are staying safe and secure in these turbulent times. So we are talking about the fundamentals and essentials of blockchain technology, a technology which has transformed the world in the last 10 plus years. Started as a specific distributed database for uh, different kind of purposes, like creating digital cash. Can you imagine? We can digitize cash. We are digitizing everything, right? So how do you digitize cash? How do you digitize money, right? So it started with something known as cryptocurrency, a currency powered by secrets. Let us understand what it is. I would like to share my screen and show to you how blockchain looks like. So, I'm sharing my screen and you can see my screen. And this is a live blockchain. You're seeing a live blockchain running on my machine. As you see, this is something called, I have started a blockchain called Ethereum blockchain in my machine, and it has created some uh, data in the form of blocks: block 0, block 1, block 2, block 3, block 4. And you can, if you click on the block, you can see the details. Every block has something known as transactions recorded in the form of a transaction hash. Hash is nothing but a long sequence of random numbers. So it has created block of data through something process known as mining. And it is using a concept known as gas, which is the computational effort. So this is a computational system. So this has mainly accounts, blocks, transactions, contracts, and events. These are the details that you have in this system. So you can add your projects into this system. So I am not going into the details now. We will try to understand what is a blockchain in this presentation. So let me do that later. I'm coming back to what is a blockchain. So I am running something known as Ganache blockchain. Ganache is a blockchain, a web-based blockchain, a desktop version of a blockchain from the type of blockchain known as Ethereum. Okay, so before starting our presentation, I can tell you, this is my terminal. Terminal is like a command line of the of my laptop. So I am running a command called the Ganache CLI. It will start a blockchain running on the terminal. This is a simple one compared to the other one you have seen. See, blockchain has accounts. Every account has some amount of storage. So you can create accounts in a blockchain and you store your account using key, private key and public key, which is a concept we use in cryptography. And you access these blockchains using wallet, which are the applications on blockchain. And see, now you can see this blockchain is running. It is generating the blocks. Okay, so let us shut down this blockchain and get back to our presentation. So blockchain technology. Here, my focus on blockchain technology. I'm going to talk to you about how blockchain technology is powering the world of business. What is a blockchain? In a simple term, a blockchain is a combination of words, block and chain together. It's a growing list of records called blocks that are linked using something known as cryptography. Cryptography is a technique of storing information very secure manner. So a blockchain looks like a ledger, a distributed ledger. You must be knowing the concept of ledger if you're familiar with accounting. The concept of ledgers has been there ever since 16th century. Ledgers have been used for bookkeeping in commerce, trade, transactions, and banking. The ledgers could be digitized. So in a blockchain, you see digitized ledger, which is distributed across different machines. So with blockchain technology, you are able to do transactions in a ledger. And when you do transactions on the ledger, you create something known as block. Block has an impact on the next block. So a block and other block is linked together, related, connected. That is why we say it is a chain of blocks. How are they chained? They are chained using something known as cryptographic hashing. You use something known as hash. You have seen what is a hash? Hash is a long sequence of random numbers and text, alphanumerals. So every block has a unique hash identity, which will be connecting different blocks together. So, and a block will have header and transactions. Headers are where you link the connections. Transactions are the place where you write transactions. So blocks are connected to each other in a sequence manner. So block 3 will be linked to block 2, which will be linked to block 1. Hash of previous ledger will be there in the current block. And every block will have a common element known as the Merkle root or the root block's number. And Merkle is the name of the scientist who invented the concept of a linked list or a tree which is connected by hashes. And that is a blockchain. It has header and body. We have link of hashes and we have a root Merkle ID. What is a blockchain for a common man? Blockchain is nothing but a digital ledger where you keep information in encrypted format, and you have the ability to connect people in the network in a peer-to-peer manner. And a blockchain is a powerful system for sharing data across a large network. And a blockchain is decentralized. Decentralized means it is not centralized on a server or a particular machine. It is decentralized across different machines, right? So that is about blockchain. So what is inside a blockchain? Let us understand what is inside a blockchain. We have seen every block contains cryptographic hashes of previous block, timestamp and transactions data, right? So that is about a blockchain, right? So now let us see the blockchain in detail. Blockchain's first block is known as Genesis block. Genesis block is the first block in every blockchain. Then you start with second block. Every block, second, third, fourth, and fifth block, that chain continues. In this chain, if you look at every block will have hash and data. What do you have in your hash? A hash will consist of a tree of hashes that is known as Merkle tree. A tree of hash consists of previous block hash, timestamp. Timestamp is the timing of the block creation, and the version of the block, and the Merkle root hash, the first root of the hash tree. And then you also write something known as nodes, Nonce. Nonce is a very small random number which is generated in the process of creating a block. And you also have a configurable property known as difficulty of creating the block. That is called target difficulty. After the block header, you have the block body where you have the transactions. So this is the basic structure of a block. Now let us look at the cryptography part of a blockchain. When you look at the cryptography part of a blockchain, every block will have key. For example, if you're creating a block, there will be a private key and there will be a public key. This is called public key private key combination. This process is known as pairwise cryptography or asymmetric cryptography, where you have different set of key for the generation of secret and the encryption and decryption of secrets. That is why it's called asymmetric cryptography. And along with your key, you also have something known as digital signature. And then you also have seen there is a hash. These are the four important things in a block. Your private key, which you don't share with anybody. And you have a public key, which is related to your private key, but you will share that with all the people. And then you have hash. Hash is nothing but a cryptographic hash, which is generated from a particular random string. And then you have a digital signature, which you generate using this combination of public and private key. All this makes up the cryptography component of a block. So what you do is hashes are generated using the combination of your digital signature, public key and private key. Hashes are linked together. Public key everybody can see. Private key will be separate, nobody can see it. The digital signature of a block is related to public key of previous block and the private key of previous block. That is how you verify a digital signature. All of you may be using digital signatures in your document signing. You must have been using for signing your documents online. So that must have become very popular now. So digital signatures are also there in the world of blockchain. Which is world's first blockchain? That is known as Bitcoin. Bitcoin is a secret currency, a currency powered by a secret network. That is why it is called a cryptocurrency. And thereafter, a lot of blockchains came. First blockchain, the Bitcoin, was created in 2009 by a person nobody knows who it is. That person is not by the code name Satoshi Nakamoto. Nobody, it sounds like a Japanese name, but it could be a British, American, Indian, or anybody. Nobody knows. So we have seen a term, Merkle tree. Merkle tree is a tree where every node in the tree, every individual item in the tree is labeled with a hash of the data, and it has a linked list of trees. This is how a Merkle tree look like. H in the diagram shows a hash function. And so you can see the topmost hash is connected to all the child hashes. You know, A, B, C, D, E, F, G, H is the root hash. From that parent, you generate two child node, hash A, B, C, D and hash E, F, G, H. From that, you generate A, B, and C, D. So A, B, and C, D are the leaf node or the end node. And A, B, C, D is the child node, and A, B, C, D, E, F, G, H is the parent node. So T represents transactions. Transactions are hashed first. Then from the hash, you generate group of hashes, and finally it takes down to the root hash. This is what is known as Merkle tree. So what is a blockchain design? Blockchain is designed as a resistant system. You can't modify the data entered on a blockchain. That is the main property of a blockchain. It is designed as a immutable ledger where you are not allowed to mutate the data. That is why it's called an immutable ledger. It is resistant to modification of the data. It is created as an open ledger which is distributed across the machines. The concept of distributed is related to the paradigm of distributed computing. So in this ledger, you can record all the transactions between parties efficiently, and you can verify the transactions by checking the timestamp and the digital signature of transactions, and store the record as a permanent record. So a blockchain has a lot of use cases. Blockchain, how do you enter the data in a blockchain? You have to send a request. If you are part of a blockchain network, you have to send a request asking permission to enter create a new block. When you do that request, your request will be validated by the network of participants. The network of participants validate your request, and then they check whether you are a genuine user, whether you have a genuine eligibility for creating a block, and then it will give you a validation, a permission to create a block. Then the block is created. You create block by spending your energy in your computer or in your network. It can be a different way. The way by which you get that permission to create that block by a network of participants is known as consensus. This is the main difference from blockchain and other large-scale databases. In normal databases, you enter a new entry by committing a query. You run a query and the query is committed. Here, instead of running a query, you are proposing a block, and if you get approval, that process is known as consensus. This consensus creates a new block, and then that block is appended into a read-only immutable ledger. And that's when you say it is a complete transaction. Instead of the normal query to database, here you apply something known as smart contract. Smart contract is nothing but a piece of code that you can run on a blockchain database. Is it not surprising? Normally, you don't run a code on database, but in blockchain's database, you can run code, or you run code which is maintained as a permanent record. So why do we use a blockchain to build a distributed ledger? To use as a distributed ledger, blockchain is typically managed by a peer-to-peer network, collectively adhering to a protocol for inter-node communication and validating the block. So it is important to have a decentralized peer-to-peer network collectively agreeing to a protocol. So this is a new type of protocol, internet protocol of value, where everyone agrees to a valuable transactions and every node communicates to each other to validate the block. This is why it is very different from normal databases. So 4 elements that characterize a blockchain are: a blockchain has a replicated ledger, a ledger which is replicated, which is shared and made the same across all the participants. So all the participants replicate the ledger. If you are somebody working with databases, you should be familiar with the term database replication. Or if you are a student of computer science, you must have heard about state machine replication. These two concepts are there in blockchain. You replicate this ledger. Everybody in the blockchain network will have the same history of all transactions, which is a read-only history, an append-only history with immutable past. You can't go back. It is like the real life, right? You can't go back in the past and change your past unless you have a time machine or a quantum computer. Blockchain is the same. You can't go back in the past and change anything. That is the power of blockchain. That is the real life similarity of blockchain. It is distributed and replicated. And blockchain also has the very good, powerful mix of cryptography. It uses cryptographic hashing. It uses digital signatures. It is also using the power of the state-of-the-art military-grade cryptography, using which you can verify the integrity of the ledger. You can authenticate and verify transactions. You can ensure there is strong privacy for transactions. You can also ensure there is proper identity for all the participants. And blockchain also has the ability to give you a decentralized control. You apply something known as consensus or an agreement in the way you enter data. Nobody can enter data in an autocratic or in a single or centralized manner. It has to be approved by all the parties in the network. That is the beauty of blockchain. It gives you a decentralized network protocol, and it gives you a shared control. So nobody can take control of the network arbitrarily and use it. Every transactions are validated by consensus. You can also apply a code into this database, which is called smart contract. It's an interesting term. Smart contract is a term which is related to a legal parlance. Smart contract as a term came in early 1990s when people wanted to create a society where you can codify every law. That is when people thought about smart contract. And that's why the founders of blockchain wanted to imagine about a society where blockchain will be used to codify every law in the society. That's why they use the term smart contract. Okay, so if we look at the attributes of blockchain again, it is verifiable through provenance. Provenance means the history. It's a provable history, and it is consensus based. It is not arbitrarily, or it is not based on censorship or a single party, right? And then it is immutable ledger. Once you enter it, you can't edit it. It's a tamper-proof, tamper-evident ledger, and it is decentralized. It is shared among all the participants. There is no single point of failure because the data is replicated across all the node. There cannot be a single point of failure in a blockchain, and it is a programmable database. You can write programs into blockchain. You can apply scripts on blockchain. So this is the power. Once recorded data in any block cannot be altered retroactively without alteration of all the subsequent block, which require consensus of majority. If you want to edit it, you should have the power to edit all the data till then, which is very, very difficult. So when you look at the history, the invention of the blockchain technology started from a currency, a digital currency known as cryptocurrency. Yeah, so Bitcoin is the first cryptocurrency to solve something known as double spending problem. Double spending problem is a major concern when you digitize money. When you digitize money or currency, you have to make sure it is not spent multiple times, because if you store or create, or if you want to send money to somebody, nobody should be able to use it multiple times. That is why it is very important that it should not be double spendable or multi-spendable. And it should be done without a central server. Normally, when you do a money transaction using banks, you use centralized gateways called payment gateways or centralized server. Even when you do international cross-border payment, you use centralized gateways. Blockchain enable you to do transactions of that scale without a centralized server. That is the power of blockchain. So if you look at the history of blockchain, the initial research papers are there even from 1991. There was a paper on cryptographically securing chain of blocks and recording timestamp of data by Stuart Haber and Scott Stornetta in 1991 itself. They wanted to implement a system where document timestamp cannot be tampered with. And in 1992, they incorporated the concept of Merkle tree into the design. But it took so long. It took another 10 years or more than that to get the first working blockchain. Remember, the Bitcoin came in 2009. So many years after the initial research concept by Stuart Haber and Scott Stornetta. So this is how you look at the history. 1990s, the original concept was proposed. And in 2009, Satoshi Nakamoto created Bitcoin and introduced the concept of a blockchain to create a decentralized ledger maintained by anonymous consensus. That power of anonymous consensus gives security and privacy to the network who is participating in the transactions. And then a lot of cryptocurrencies came from 2010 onwards based on the concept of blockchain. And then people started using the fundamental data structure. So what is the difference between Bitcoin and blockchain is Bitcoin is the currency. Cryptocurrencies use blockchain data structure. Okay. And blockchain technology is the technology around the data storage in the format of blockchains. So people started using it for wider use cases ever since 2012, like different banks in Spain and across the world started doing currency transfer and digital payments on blockchain. And then financial markets have started using blockchain for smart contracts in the early 2014-15. And then till then it was all open blockchains. But from 2015-16 onwards, and the closed blockchains without cryptocurrencies started coming up by the Ripple, Eris, and a lot of other blockchains like Hyperledger. They all came up, and that begin the starting of enterprise blockchain technologies, and then companies started using blockchain without the currency angle also, and that's what we are seeing now. There is one side public blockchains which are used by entrepreneurs and startups to create cryptocurrencies and do transactions on a new market. Another side, we have big corporations like IBM, Microsoft, Facebook, all trying to create their own enterprise version of blockchain. And there are some others who want to create a mix of both. So we have studied till now the key components of blockchain. It has cryptography and it has the power of distributed systems. So in cryptography, we use hashing, public-private keys, and digital signature. And so blockchain has now become a very wide spectrum, a rich world of possibilities. You talk about distributed systems, cryptography, new kind of politics, and new economics, right? So blockchain, if you look at the evolution of blockchain from the 1991 to 2020, it has gone through different manifestations and metamorphoses. Initial blockchains were only surrounding the protocols and currency, but now we talk about different industries, different legal aspects, different non-economic aspects. So blockchain as a concept, right, is now having wider implications. It is now like different types of blockchain. Public blockchain, which is the early blockchains like Bitcoin, Ethereum, Litecoin, all of them are public. And then there are federated blockchains, which are created by consortiums, corporate consortiums for banking, insurance. Example, R3 is a consortium of banks and financial services companies. B3I is a consortium of companies who have created insurance-specific blockchains. Then there is Enterprise Ethereum Alliance of companies like Microsoft, IBM, Intel, Cisco, etc. And then every company now creates their own private blockchain. So blockchain technology, if you explain, is all about a request to create a net blockchain in a new block in a network. Then that request is validated by the network. There is an audit trail. There is a history of this request. Nobody can fool with the blockchain network because every request to add a block is always kept in the ledger. And everybody in the network can see that audit trail, that history. And then that is validated by the network. That is the democracy. That is the power of the network. Once it is validated and verified for the genuinity, originality, the uniqueness, it is then approved and the block is created and the transactions happen. Blockchains can be used for different kind of use cases that we have seen. It can be used for large scale use cases like currencies, like Bitcoin, which can be used for different, like it's a large economy itself. There are more than $200 billion getting transacted on Bitcoin. There are 10,000 nodes which are maintaining Bitcoin. And one Bitcoin is equal to around 600 US dollar now. And then there are so many people using Bitcoin in the world for buying land, for registering companies. It's an economy together. But it need not be such a large use case. You can also run services on blockchain. You can create named services, identity, land ownership, membership to networks. You can also do voting on blockchain. You can create smart contracts for notarizing your will, your agreements, everything, every kind of possible legal smart contracts can be written on blockchain with proper judicious review. You can also create organizations on blockchain called decentralized autonomous organizations. So billions of users to thousands of users, different scale and scope of use cases can be done on blockchain. You can also, when you look at an architecture, there are different kind of architectures of blockchain, right? Ethereum is a public blockchain, which has a very open source application structure. Hyperledger is a blockchain started by Linux Foundation, and then all the leading corporations support it. There are a lot of blockchains in the Hyperledger. Hyperledger has come up with a family of blockchains. Corda is a financial blockchain system. And then you build applications on blockchain, and then your blockchain can talk to different databases and services in enterprises. But there should be a proper a kind of verification, because there is so much of hype around blockchain now. Everybody want to do everything on blockchain. Such a trend is not welcome. That will create unnecessary hype around blockchain, and then will kill the genuine value of blockchain. That is why nowadays people are very much, very much in favor of a good checklist for blockchain. So you need to think what all are, what type of transactions, what kind of systems can be built using blockchain. Blockchain cannot be used for every database, each and every database, right? That's not a very good approach. That's why this checklist is very useful. So what is there in this checklist? First, you have to check. If somebody says, I want to develop a blockchain, you have to ask him, what are you storing in the blockchain? Are you storing the state of the system? If it is not required, if it is a stateless system, you don't need a blockchain. Then you have to check, do you want the access to multiple parties? If it is only single party access, it is pretty much a centralized system. Then you don't need a blockchain. Only if multiple parties need to access it, you need a blockchain. Then you need to check, is there a trusted third party? If you need a trusted third party, like a bank or a payment gateway, again, it's a centralized system. You don't need a blockchain. If you are sure you don't want to use a centralized system or a trusted third party, you can go to blockchain. So then you need to decide, do we need all this party to know each other? If all the parties need to know each other, then you can go with permissioned blockchain, where you give permission to everyone. If anonymous people can join, then it is fine to have a permissionless blockchain or an open blockchain. Even in a permission blockchain, there is a category. Should it be public or private? If it is public, it is public permission blockchain. If you want to keep it private, inside an organization or selective to a group of parties, then you make it a private permissioned blockchain. So these are different variants of blockchain. Blockchain, like I said, we should be always away from the hype and the unnecessary complications around it. Blockchain has to be used only when there is a real purpose for it. So you have to understand what is the purpose. Is there inefficiency in the system? There should be. So whenever we apply blockchain, we look at the system? Is there a process inefficiency in the system? Are there duplications in the system? Then we support use of blockchain. Then do we have multiple parties? Do you want to remove trusted third party or intermediary? Then you go ahead with blockchain. And then what is the cost due to inefficiencies of several parties? That is another factor. If there are inefficiencies because of multiple parties, that is another reason you go to blockchain. And then is there an issue of distrust among the parties? That is another reason. If people don't trust each other, they want to trust cryptography, then we go to blockchain. Then what kind of visibility you want to give? What kind of immutability you need? These are other factors on which we decide a blockchain. There is a serious difference between blockchain business model and the traditional business model. This is very important to understand. That is why we say blockchain is a new kind of internet. Blockchain is a new internet where we give more importance to protocols. See, when we started, we created the early internet in the early 1960s and 70s. The importance was around protocols. Likewise, even now, in the world of blockchain, we give importance to new kind of protocols focusing on consensus algorithms. These algorithms help us to creatively decide how to commit entries into a blockchain database. So blockchain gives more importance to protocols than applications, at least in the initial times. Maybe in the future, we will give more importance to applications. When we have good standardization and good decentralization, we'll start giving more focus on applications. But now the focus is on protocols. We have different kind of protocols. Protocol to govern a blockchain, process data, store data on blockchain. Different protocols are there. That's why blockchain is a Cambrian explosion of protocols. So blockchain can be used for business, different kind of business. It improves the time for settlement. It improves the process efficiency. It improves the security of your data, and it gives you better traceability on the transaction request, right? So when you look at a business of blockchain, first business models should be around just storing digital records. Then the second type of business cases could be around exchanging digital assets. Then the third type of use cases could be around executing smart contracts. So blockchain can be used for different industries now: finance, agriculture, media, healthcare, education, finance, real estate, government. These are different industries. Let us look at some of the prominent use cases. Blockchain is used in supply chain prominently. You know, supply chains have lot of intermediaries, multiple type of ledgers, especially when you deal with supply chain finance. Supply chain finance, you deal with multiple type of ledgers. There is lot of reconciliation issues, settlement issues in multiple ledgers. You have duplicate copies of data in multiple ledgers that create a lot of confusion and chaos in blockchain. That is one of the reasons we introduced blockchain to supply chain. Another industry is insurance, where you want verification of claims. You want to make sure all the claims are genuine, and all the claims should be audited and reviewed. That is the reason you bring in blockchain for insurance. Another industry is healthcare, where you want better security for your electronic health records, and you want better control on the data exchange between different parties like hospitals, insurance companies, patients, doctors, etc. There are other use cases where in real estate, you want to have a fractional ownership of a property or a building or a shopping mall. All that is possible using blockchain. You can have improved control over the property ownership. You can also link it with a land registry. You can also put a land registry on blockchain. There are other use cases like digital identity. You can secure your digital identity better using blockchain, be it Aadhaar or any other digital identity or passport. All these digital identity records can be secure using blockchain. There are other interesting use cases like voting, energy trading, uh, loyalty tokens in e-commerce and retail, and then converting organizations into decentralized organization, or intellectual property rights management for music and games, and then banking, storing know your customer record, and doing cross-border payment. These are different other use cases. So the number of use cases in blockchain are numerous. Like I said, intellectual property, government services, travel and transportation, media entertainment, supply chain, food safety. Food safety is an interesting use case where you can check whether this particular food is organic or this is coming from genuine farms. These are the benefits of using blockchain for food safety. You can also use it for trade finance. You can also use it for better payment in oil and gas industries. You can also find other use cases in healthcare for getting rid of counterfeit drugs, which is very important in the COVID era, right? We want to make sure we are getting proper drugs. We are currently in the process of building blood banks and blood banks in blockchain. These are very relevant healthcare use cases. You can think about a lot of use cases. If you see this diagram, you can see some of the early adopters of blockchain across the world. You know, the companies like Uport has created digital identity on blockchain. There is a browser, Brave, which is securing the user data on blockchain and tokenizing the attention of users in the browser, called in Brave attention token. So governments like governments of Estonia, United Kingdom, Ghana, Sweden, and Thailand, United States, Dubai are all using blockchain for land records, land registries, and different other use cases. Companies like IBM and Microsoft and Amazon and Intel and Cisco and a lot of others, they are building blockchain infrastructure platforms. And companies like Medrec and Gem and Vital Health, they are building health record systems on blockchain. Companies like Steemit and Akasha are building social networks on blockchain. Companies like Kodak and Yujo Music are creating media systems on blockchain. Open Bazaar and Loyal are creating retail systems on blockchain. Diamond companies like De Beers are building diamond ledgers on blockchain. So these are numerous use cases. So if you look at agriculture, possible important use cases are to verify the list of farming inventory, to enhance agricultural supply chains, to modernize farm management software, to use agricultural IoT systems for fair pricing and to make sure you are getting minimum support pricing, and to make sure you are properly distributing agricultural subsidies, and also for commonly supported agriculture, for giving faster payment for small farmers, and incentivizing sustainable practices. These are different use cases of blockchain in agriculture. Blockchain also has great use cases for automotive industry. We can create vehicle identity. For example, we can create vehicle Aadhaar on blockchain. We can do second used vehicle commerce on blockchain. We can also make sure the vehicles are, you are adhering to the environmental standards. You can also automate maintenance and reward safe driving practices You can also automate payment in the petrol pumps and the vehicle commerce. And also we can do smart contracts for vehicle finance and automate insurance, vehicle insurance, and then theft prevention, and then also better sharing of vehicle documents. These are different use cases of blockchain. In government sector also, we have a lot of interesting use cases like maintaining the record of welfare distribution, digital identity, healthcare, protection of digital data, better distribution of the information about taxation. These are different use cases. So when you implement blockchain, you have to think about a strategy. You need to identify what are the issues and problems you want to solve with blockchain. Then you have to trial with a prototype, and then you have to develop a proof of concept, and then you roll out a blockchain solution. Blockchain could be public, private, a hybrid, or a federated blockchain. Any of the four types of blockchains can be deployed depending on the type of industry, the type of regulations, security, and all other rules of that particular industry. For example, in government industry or government sector, you may go with federated blockchain or a private blockchain. But in media and entertainment, you may go with a public blockchain. In a land registry also, you may go with a public blockchain. So different different strategies are relevant for different blockchains. So I think I have covered some of the pertinent points, essential aspects of blockchain technology, and you also see a working demo of blockchain. I can show the demo once again for those who join late. I am starting my blockchain instance in a desktop application known as Ganache. The Ganache is the Ethereum type of blockchain. So I am quick starting Ethereum blockchain. There is one more type in my system called Corda. So when I start the Ethereum blockchain, it will show you a blockchain. What all do you have in a blockchain? You have list of accounts. Just like in a bank, you have accounts. Blockchain ledger has accounts. Every account will have address, will have some balance of cryptocurrency, and then if you have done transaction, the transaction count also will be there, and the index will also be there. There will be keys, public key and private key for every account. You also have block. When you do a transaction, you see a block. Then transactions, there are no transactions when I restarted the blockchain. So how do you do a transaction in blockchain? You can do transaction on blockchain through smart contract. So let us do a transaction on a blockchain with a smart contract. This is a smart contract. You can write smart contract online using something. This is Ethereum blockchain. So Ethereum has an online code creator called Remix. When you go to Remix, from Remix you can write code and deploy code on blockchain. So what do you have in Remix? So, this is the Remix environment. In Remix environment, you can write your smart contracts. Let us look at a simple smart contract. This is a smart contract. It is written in a language called Solidity. It is a new language. This is very similar to JavaScript, and this is written, but it also has some properties of C++ and C language. See, it has a concept of inheritance and some other property, but let us not look at the details of the language. We have a contract. This is a contract for voting. That's why it is known as ballot.solidity. I am now compiling this smart contract. This smart contract is written on the version 4. So I am using the compiler version 4.26. Language is Solidity. And then I am going to compile this contract. I compile the contract, and then after compiling the contract, I am going to deploy the contract. So the compiled contract is available. Now I can deploy it. When I'm deploying, I can deploy it to this particular environment. So I'm connecting to the local environment. How do you know it is that environment? Here I can know it from the port number. So I have to give the port number here. Let me give the port number. I've connected to the environment. Now I am going to deploy this contract, ballot.solidity. So I am going to deploy the contract. I am deploying the contract. I can see the contract is deployed. So if you look at the details, you can see the contract is deployed here. The contract has a transaction hash, and then it is deployed from a from address to another address. So every contract will have an address, and every contract in Ethereum uses a particular computational effort called gas. This is like the gas that we use for a car, right? Gas is the term used in US for petrol. When you fill gas, you run the car. Likewise, this is the concept of a gas to run a computer. And then this is the transaction hash. Let us see if it is deployed. We will come to our here we can see there is already a transaction. Earlier there was no transaction. This is the transaction. This is the data. See, data is encrypted. You can't read anything about your transaction. This is the security. It is stored. This complete transaction data is in the form of digitally encrypted information. That's why, but you can know it has used gas. You can check it has used 4,96,563 gas. That is the gas here. And then you can also see the gas limit. So this transaction was a contract creation. So now let us go to block. You can see we have a new block which is created now. The block has a transaction hash. It is from one account to the contract address. So now you have account. You can see there is a transaction on one account. One account, there is a transaction count. So we deployed a transaction. This is the simple blockchain, but this is an Ethereum blockchain. We can create a blockchain. When you create blockchains on Ethereum or Corda, sorry, on Hyperledger or Corda, you don't have a cryptocurrency. You just have concept of smart contracts and a ledger. But here,
Hello. Hello, sir. You're not audible.
Hello. Gokul, you are not audible.
Hello. Hello, sir. Gokul, sir. Hello.
Hello. Hello. Oh, I think he got disconnected.
Yeah, sir. He has left. Maybe we'll join again.
Yeah, he will join.
We'll wait for 1 minute.
Yeah, in between the session, let me continue.
Okay, sir. Yeah.
Yeah, Vishwanath, yeah, we are waiting for Gokul. Maybe there may be some network issues. Yes, and hi, this is Priyadarshi. Nobody. Hi, this is Priyadarshi, and I do represent Edumentes. And thanks, Digvijay, who had conducted the session. And yes, we are starting our blockchain course, and Gokul will be our first instructor.
sorry, I had a power outage.
Yeah, please,
I had a
Gokul.
power outage at home.
Yeah, Gokul. I was just handing over, so compensating
Sure.
that. You carry on.
So sorry, everyone. I had a power outage. I hope you got a demo of an understanding of the concepts of blockchain. If you have any questions, I'll be happy to address them. Otherwise, you can always connect with me through Mr. Priyadarshi and Digvijay. It'll be my pleasure to. There is a question: what is the scope of non-technical students to learn blockchain? It's a very interesting question. If you look at the blockchain technology, see, it is not about computer science students. Everybody can use blockchain. See, blockchain is a new internet. So we need people to do business on blockchain, business analyst. You need to build products on blockchain, product management, sales on selling blockchain. So industry needs more and more business analysts, project managers, product managers, marketers on with understanding of blockchain. So it is but only if you understand the paradigm of blockchain, paradigm of decentralization, paradigm of internet of value, a new paradigm of trust, transparency, then only you can communicate to governments, business, and public about blockchain. So now world over, companies are hiring blockchain business analysts. Companies are also hiring blockchain product managers, blockchain pre-sales, client architects. So these are numerous opportunities for non-technical students, especially with background on MBA, with a background on finance or marketing or sales and technology management, of course. You will grade the addition to the blockchain. So there are a lot of things you can learn about the business side of blockchain. That is something like business models on blockchain, because blockchain business model for supply chain will not be the same as healthcare. That will not be same as media and entertainment. We need different business models on blockchain for different industries. So people with good background on those industries can play a very good role in blockchain. That is not only for students, even experienced people with good background on healthcare or finance or supply chain or media and entertainment or governments and public sector can play a very good role in the world of blockchain. Any other questions?
Yes, sir. This is Digvijay.
Yeah,
There is the same question. What do you think the applications in logistics, supply chain, and marketing?
Yeah, supply chain, there are huge opportunities. Basically, in India, now we know there would be direct, you can buy agricultural commodities directly from farmers. So we are going to see greater market access to farm products from this year onwards. New kind of commodity trading, the more integrated supply chains we are going to see in the coal industry and in the agriculture industry. So we are going to see better blockchain use cases of blockchain. For example, for food, mainly food supply chain, commodities, metal related supply chain, and also for agriculture supply chain and different other supply chains, we are seeing a lot of applications of blockchain and a lot of entrepreneurs and blockchain. There is no concept of an ownership in blockchain. When you look at if it is an open blockchain, everyone is an owner. When you have a private blockchain, there could be a creator of blockchain. You initiate a blockchain, but afterwards, if everyone join your network, then it becomes decentralized to everyone. Then if everyone create their own transactions, for example, even if you're hosting the entire blockchain on your cloud and everyone is running it, you will not have access to every block. You will have access to your cloud, but you will not have access to the every block. If you are the only one creating all the block, you will have access to every block. Then it is not a blockchain. It is just a database. Only if multiple parties access and use, it's a blockchain. If multiple parties are accessing and using blockchain, everyone will have their own copies of blockchain. Then single party cannot delete or remove it. Another interesting question, a public blockchain, if it is using a specific type of consensus called proof of work, it is energy intensive because the consensus algorithm is based on computational work. There are a lot of other consensus algorithm based on the stake you have, the number of the overall stake of currency you have. Then that is not resource intensive. There are numerous consensus algorithms. They are not resource intensive. One of them specifically used in Bitcoin, that is resource intensive. This is because it was designed as it is. But there are numerous other blockchains which are not resource intensive. So it is an assumption that every public blockchain is resource intensive. Only Bitcoin, because of its design, is resource intensive. Any other question?
Hello, sir. Can you tell what computer language is required? Like, what is the proficiency required for this blockchain?
You need to have a good fundamentals of internet. You need to know also the fundamentals of computer security like cryptography and digital signatures and hashing. Some of these concepts which you can learn in a matter of a week or a couple of days time. That is only necessary to get started with a blockchain. Otherwise, this is not a very difficult area. You will learn everything on the process, on the course of learning blockchain, because it requires a lot of new understanding. No, you can't modify the data that you write on a blockchain. When you try to modify it, if the blockchain is running, you can't do it. When you shut it down, you can edit it. If you have the complete blockchain stored in your machine, only in your machine. But that means when you restart it, it will become a new blockchain. So in a live blockchain, unless you have a very, very, very powerful quantum computer, which is not possible in the current reality, current state, you can't edit a live blockchain. If you shut down a blockchain, you can manually go and edit the data. But when you edit it, it becomes a new system. It will no longer be the old blockchain. So in that sense, it can't be edited like a database. But in a database, if it is running, you can log in with your administrator account and edit it. Such things are not possible in a blockchain. Any other questions?
So I have a question. Like, it might be silly. Like,
No,
what about the
no
privacy and
worries.
security?
Nothing is silly.
Like,
Everything is important.
yeah, what about the privacy and
Yeah.
security in the blockchain? If one block is hacked, let's say through a bug, or, as blockchain is interlinked, right? All blocks. So wouldn't it lose all the data might lose and can be
The
hacked?
privacy in a blockchain, see, initially when blockchain was designed, it is built around the concept of pseudo-anonymity. That means everyone is known by their public address, which is created from the public key. There is a 256-bit hash. So you don't store your name on your account. You have seen the live blockchain, right? There is no name on a blockchain. Only you have a public 256-bit hash address. So it has pseudonymity. But now, using advanced computers and machine learning, there are some algorithms to track the IP address. So now there are privacy preserving blockchains coming up, which are very private. So so there are specific blockchains created for privacy, like Monero, Zcash, Coda. There are different blockchains with very good privacy. Bitcoin only provides you pseudonymity. Ethereum only provides you pseudonymity. But they are all upgrading to greater privacy in the near future. Security of blockchain is through power of cryptography, cryptographic hash functions, public key cryptography, digital signature. It is very secure system. Till now, nobody, it is, Bitcoin started in 2009. We are in the 11th year. Till now, Bitcoin is not hacked by anybody. It is live system. It is running live. So many blocks are created. So much of money has been transacted. It is still unhacked. Ethereum was hacked because there was some vulnerability on the client, the web client which was created. But then they forked it, and thereafter, it is not hacked anywhere. So all the public blockchains are very safe. Even the private blockchains like Corda and Hyperledger, there has been no instance of hacking or security issues in any of them. So, it is way more secure than a normal database because it has asymmetric cryptography. It uses elliptical curve digital signatures. It uses SHA secure hash 256 double times. It's way more secure than an average database that you have in the market. Yeah, so there is another interesting question. If a block is created and maybe not used after that, that space is unnecessary. Very valid point. So that is why all these public blockchains are applying something called pruning. They prune the blockchain database. They compress the header and make sure that space is used efficiently. So that is, so many space optimizations are done on real blockchains now. So there is no such concerns on the space of blockchain. But it is true that it takes more space and time than a database. But that is because it is providing more security, more wider access, right? A normal database is only used by a single DBA or a selected few. But a blockchain, Bitcoin is used by 10,000 people simultaneously. Such concurrency, such parallelism is unprecedented in the history of computer science. Any other questions? You can always connect with me on LinkedIn and Twitter. I am available on LinkedIn and Twitter. You can connect with me. I'm on LinkedIn, Twitter, Instagram, Facebook, and all other social networks. And you can always connect through Priyadarshi and Digvijay and the Edumentes team. So from my side, I am really grateful to this opportunity, wonderful opportunity to talk to a lot of new friends and a lot of technology enthusiasts and business enthusiasts. And thank you so much to Priyadarshi and Digvijay.
Thank you, sir. It was a pleasure. It was very informative. Thank you. Thank you so much. Yeah, now Videshi sir will take over. He wants to talk about the course content.
Thank you, Gokul, for sparing your 1 hour to explain the details to our candidates and our students. Basically, we are an Edumentes education advanced tech education organization who are supporting basically to tier 2 cities. Our agenda is to take advanced technology and deep technology to tier 2 cities like basically Bihar, Jharkhand, Chhattisgarh, Odisha, and even Nagpur, Nasik, Rajasthan. These are our target areas. Even to Maharashtra, apart from Pune and Bombay.
It's a great initiative. It's a great initiative. I'm really thankful to you because it is the need of the hour. Let us use this opportunity to spread the power of this emerging technology across our tier 2 cities, because you must have seen how interesting and very original, creative questions they have raised. There is so much of intelligence in our tier 2 cities, untapped, unharnessed. So this is a great mission.
Thank you. You are supporting, and yes, we are happy to announce. Yes, we are starting our first batch with a nominal amount. The amount is not that big, and Gokul had supported us to be a part of it. I know it's a very nominal amount, Gokul, but thank you for helping us in starting this
My pleasure. My pleasure.
Yeah, and with where Gokul will be helping and giving the blockchain with some specific use cases, which we had asked to Gokul, because we are getting candidates who know how to code a bit, but they are not accustomed to the specific use cases, which
Okay.
comes with experience.
Understood.
That is what the reason we had invited you, and yes, you had explained it in a very, very best way. Okay, so we would like, yeah, thank you again, thank you Gokul, and I would request everyone to connect to Digvijay if anyone are interested for the course curriculum, and thank you everyone for spending 1 hour for this session. Okay, Gokul.
Thank you, everyone. Thank you, Priyadarshi. Thank you, Digvijay. Bye-bye.
Thank you, Digvijay.
Thank you. Thank you, everyone.
Thank you.
Have a good day. Bye.